This
authority.
conference will now be recorded.
I have it on good authority. We can talk about it apparently. So, all right. So let me share. Let me first make sure that I've got the screen the way I want it, without any extra content.
If there is a public document, I could probably put the link in the chat if that helps. Is that what you're intending to present?
I don't see it in chat. I see Yuval's statement in chat, but
yeah, send the link to them.
problem is I'm logged in, and so to me it looks like, yeah, I can get to it, but I wasn't convinced that it was something I could talk about. So,
Oh, let me see. All right, here we go. It's not. Wow, pasted pretty huge in the chat, I think. Did that come through?
I still see Yuval's paste. I don't see yours.
No, if you bind the
Something weird. Something weird happened when
All
I pasted.
right, I guess I found it too. So, all right, well, let's get going. I guess I was misunderstanding our state. So, if other folks are able to get to it too. So, all right. Okay, so let me share my screen and we'll get started.
That window, for some reason, it doesn't like auto scroll. So you'll probably see a link at the very bottom. So because you've all typed in the first message.
Yeah, that's the same. That's the same thing. So if you can get to it, then it's available. So let's get started. Screen 2, share. So Yuval and I both work in the standards body group. So we'll both take questions as we go along. Some of these slides are actually probably a repeat from the prior slides that I gave. I may skip over some of them. Standard disclaimer that this is just a snapshot of the work being done in DMTF. Don't go off and implement it. And it's subject to change without notice. And this is just for feedback purposes. Also an acknowledgement that some of the material that you'll see in here is based on the USB Type-C authentication specification. And you can find that specification out on the usb.org site. We talked about this last time. Essentially, we intended to create a special Type 5 code for the purposes of establishing secure communications and providing mechanisms to pull in firmware measurement methods. Additionally, we had proposed, I think even last time, that we would have a Type 6 for the purposes of encapsulating various MCTP messages. And I'll go into some of the detail as to how to differentiate between Type 5 and Type 6 MCTP messages. But think of Type 5 as how do I establish a secure channel, knowing who I'm talking to, as well as the actual measurement transmission. Think of Type 6 as if you had content that you wanted to encrypt using the standards protocol, you would use Type 6 and as an encapsulation method. So from a Type 5 security command format perspective, this is how we envision the packet to look. It'll have, it'll talk about what protocol version you're using. It'll ask for specific commands, and then you will have specific replies to those commands, some of which will be maintained in the data section of the payload. It'll write over This particular format should not require, none of the things we're doing should require ASIC changes to enable the functionality, unless example would be your chip doesn't support encryption to begin with. That's a whole nother matter. There is a protocol, a set of protocol commands that enable you to discover an endpoint, and then for that endpoint to actually reflect the capabilities of the part. The capabilities of the part could be everything from, I support RSA 2048 up, or I support 4096. So it's both the types of encryption and certificates you can manage, all the way down to actually you have no support whatsoever. And of course, if you don't reply to the type 5 message, then clearly you don't have even that support. So this is just the format of what I've just discussed. You'll ask the endpoint what's your protocol version you support for type 5. And then you have the message types and the responses that go along with that, along with various parameters that make that request happen for type 5 messages. So from a number of commands requests, this is actually part of USB. What we've done is added some additional, so we're piggybacking that protocol, which incorporates get digest and certificates and even challenge responses. On top of that, we're adding in get measurements, get capabilities, set certificate, and negotiate. And each one of the slides below actually gets into what do each one of these items accomplish within the protocol itself. In the response codes, we have the matching to the request codes, where you actually provide the measurements, the capabilities, the certificate response, the algorithms that you're capable of doing. And again, you can see the piggybacking of USB, where the response codes that were formerly provided by that protocol are provided in the top. The additional responses are provided in the bottom. From a digest perspective, this enables you to get a certificate chain. So you're able to go query the device and get whatever digest, the certificate chain from the authority all the way down to the endpoint device itself. You can retrieve that from the device, or at least it enables you to do so. The response to that request is, basically that information. You can, it allows not only for the digest itself, but if an endpoint device supports a specific number of slots, you can actually go in and ask for, say slot 1 instead of slot 0, by example. The way we see that being sort of implemented by endpoint devices, at least many of us view this as the mechanism for which you would enable change of ownership, transfer of ownership for an endpoint device. So an endpoint device would likely come in with slot 0 populated by the manufacturer. Then you could go in and take ownership of that part, and you would actually set up slot 1 with your own information. You could then go in and query slot 1 for that digest for the data that represents the ownership that you've taken of the part. Conceptually, all those ownership of transfer rules could also be applied, and you could actually use these mechanisms to also enable back to market selling by disabling slot 1 and using just slot 0 for in other words, you wouldn't erase a slot when you returned it to the market. You would just go back to slot 0 use, by example. This actually allows you to get the certificate chain. information. And again, you can use this as a mechanism to target whatever slot you want off of it, want to use for the certificate itself. This is just the response to that certificate with the data that's returned with it, along with the slot number in use. The challenge request enables you to prove ownership of the actual credentials that you provided. So you can ask the part once you receive certificates and associated public keys. You can say, well, hey, do you actually own the private half of this thing that you've presented to me? So the challenge request enables you to provide that interaction with an endpoint device. And of course, this provides the mechanism to provide the actual answer to that request with all the data that's associated and with the challenge request that was given, so that you can, when you get the data back, you can actually validate that the challenge is authentic. So in theory, once you've gotten the digest and the certificates, and you've proven who that endpoint device is, the likely next thing you would do is ask for measurements. And so the get measurement request enables you to get a set of measurements from the device, more than one. It also provides the ability to inject some randomness into that measurement request. So clearly, you don't want an endpoint. You want to prevent the ability of replay. And so the very last item in this get measurements request is the randomness injection, so that when you get the measurement back from the device, you have a method to assure that the measurement was fresh.
Can you describe how that gets incorporated in the measurement? Or is that what this will? You go through that here? So
the methods that an endpoint device incorporates the nonce is not a part of the protocol. In other words, none of these things that I sort of labeled actually define how an endpoint responds and generates these requests, the responses to these requests. So by example, if not preferable, but let's say that nothing was available in hardware and some endpoint implemented everything in software and it was fungible, you could, or any portion thereof, right? As you're responding to these requests, they could be software generated endpoints. So how the nonce is incorporated is not necessarily defined by the protocol, but clearly it needs to be a defined process for incorporation, so that the other side knows how that nonce was incorporated to prove the freshness of the measurement.
Is it envisioned that these messages are going to be sort of transmitted over an encrypted channel?
So type 5 requests themselves, in theory, are not part of the encrypted channel. So I think what I hear you asking really is the measurement in the clear? Can someone just take a snapshot of it and replay it? Not described. Well, go ahead.
I was going to say not the measurements per se, but the nonce itself.
Okay.
If it's being transmitted in the clear, then somebody could abuse that with some sort of man-in-the-middle attack.
So a couple of things that came up the last time we met, where I asked you some questions about what you were willing to accept and not accept, and it didn't go well. That is something that is not described in the slide deck as to how we might protect the running transaction. But it is part of, I don't know how much more I can really say. It's I think it's actually maybe in the last slide where we talk about it, perhaps. But in a future rev of this spec is where we hope to incorporate protection for the question you asked.
Okay. Okay. Yeah. There's a, after the whole sort of super micro speculation, there's a lot more concern about rogue hardware on the boards.
Sure.
So doing sort of end-to-end secure channels is becoming more and more important.
It's not lost in what the work we're doing. It's not even an oversight. It's just we really wanted to get what we had out in the open a bit so that we could start getting feedback on it. And where we sort of drew the cut line was that conversation right there.
Sure. I think that's totally fair.
Okay. So this is the measurement response to the request, and part of the prior question was, well, how do we know what algorithms in use, and that sort of question would actually be part of the agreed upon negotiate phase. So clearly you can't do measurements and you can't do calculations with nonces unless you actually know what the algorithms in use are going to be for each of the endpoint devices, as well as even the platform root of trust, right? So you sort of have to negotiate what you're going to be doing when you do measurements, even the certificates in use to prove who you are, the challenge responses, all these things have to be part of some negotiative process so that in various disparate endpoints in a platform communicating with a root of trust can agree as to how they're going to communicate. So there's a bit of an assumption here that in a multi-vendor environment that we're likely to encounter endpoints that have a lot of different capabilities based on the ability for a particular vendor to deliver something to market and the timing that they do it. So the notion behind this is you will spend some amount of time in these transactions doing a negotiate phase, the end of which could end up either being the platform root of trust just will not talk to that device because you couldn't negotiate down to a thing that you could both agree on. And I think there's some additional negotiate requests further down in the presentation. So kind of out of order a bit because we did all the measurement stuff. These get capabilities requests would actually happen before you did some of those other actions I spoke of, because you have to know the capabilities of the device and then you have to negotiate it. So in this particular transaction, you're saying, hey, endpoint, what are you capable of doing? And then this is part of the capabilities response, in which you say, hey, I'm capable of doing these bit settings in terms of, okay, hey, I can do digests and certificates and set certificate and get measurement. These capabilities responses are mainly about within the protocol itself, what are you capable of doing? What can you satisfy? It's not really about the negotiate phase where you're actually talking about what algorithms are in use. So again, not exactly in the order of operations. I think in the future we're going to have a ladder that talks about when in the transaction these things occur, which will be very helpful because I know internally we've had quite a bit of discussion about what should come first and what should come second. So I apologize that these slides aren't actually in order of the ladder. So from a certificate request standpoint, this would enable you to set a certificate within the device, assuming you have the permissions to do it.
Like what are those permissions? Like what's the authorization for being able to do this? How does that work?
I think there's actually some content missing around this, but what you would want to have is an authentication piece that says, hey, as a certificate chain came down, it's an allowed operation. So by example, if you just willy-nilly allowed someone to set up a slot, it could mean just about anything to that endpoint device. And so you would want a mechanism where you have some material associated with this request so that the part knows that this is a valid thing to go do.
Okay.
Is there any sort of plan to flesh out the details for how ownership can be transferred? How you sign these set certificate requests so that they can be authenticated by the device.
I think that's some good feedback. It's not something that I think it's something that's somewhat missing from this deck. Is it's one thing to go in and elicit how a protocol works. It's a little different to say, well, how to use that protocol to enable something. So my point there prior to your question was, well, I think there's some data missing here. The data missing here would enable that process. That process should likely be documented somewhere as to how an endpoint would use a particular field in order to prove out the setting of the slot. And I think that's good feedback that the working group likely needs to provide not just the protocol itself, but how the protocol can be used.
Yeah, I think just some either as guidelines or may not be part of the specification, but I think just having device vendors that are not necessarily security aware understand how they need to verify these requests would be great. One other question I had, I didn't see anything about getting a measurement log here. And maybe that's part of how the measurements are retrieved. Maybe I missed it, and there's an indicator in there of what the represent.
Okay, I think we haven't actually gotten to the get measurement request or response.
Oh, sorry.
I don't remember showing that, but maybe I already passed through it, but I don't think we did. I think it's in one of the remaining slides. So let's either go back to the measurement slide that I passed over too quickly, or get to the one that has it, and then we can talk about that.
Okay.
And this is just a response to doing the set certificate that it was asked to do. So in the negotiate portion, again, I think I find this a bit out of order from all the other slides that we have. You're essentially, so one was about capabilities of the protocol. This one is about the algorithmic items in use and how they're used and what the device is capable of from a cryptographic perspective. And so you would say, well, hey, I want to support 4096, and you would use these negotiative requests and responses between the endpoint and the root of trust to align to something that both could support.
One quick question here. I'm assuming that there's going to be some definition file that defines what each of these bits mean. Is there going to be some ability to define additional bit algorithms? I'm thinking about ED25519, which is popular or becoming popular, and we've seen with the TPM2 case, there are the Chinese specific ciphers that are required to deploy there. And so, one option is that you go to the standards body and you request another bit be allocated for the algorithm, and the other is to have some sort of extensible thing where you can report back that you support some additional algorithms.
So I think that is somewhat allowed here in the area that I'm highlighting, where you can do a list of, it's an extensible data structure that enables you to actually do that type of support without necessarily having to go back and define bits. Because that is a point of discussion, is that, well, how do we actually enable a self-describing data structure so that you don't have to always go back into standards to get a new bit defined? So there was sort of this compromise discussion around, well, here's some base algorithms in use, and then here's how we might extend it so that we could get more than just a certain number of bits defined with a certain number of algorithms.
Okay, makes sense.
And in reality, some parts might not support any of this in the bottom. They only really support these bit vectors for base algorithms and hashes. So, all right. And this is just the response data for that request, where you respond back with, well, here's what I can do. I'm not really sure. We don't need to really cover the error response. I don't think we need to do the timeouts. So let's go back to, I must have passed over the measurements request. Okay. There we go. Okay, yeah. Your question, I had already gone over it. So in the response data, you get the number of measurements in question, and you get the length of the measurements and the concatenation and a signature on it. Your question specifically, though, was if you would restate it, that would be great.
I was thinking in terms of some sort of measurement log, so that when you're trying to recompute the measurements, if you need to replay the measurements, you know what each measurement represents.
Okay.
So you see this, I mean, maybe I'm just coming at this from a TPM sort of centric standpoint, but you know, the PCRs have measurement logs associated with them, which allow you to replay the measurements to reach the final value, and also allow you to look at each component in the measurement and individually check that they match some sort of whitelist. I guess sort of stepping back, is it envisioned that there's that there's some sort of PCR type of extend only register here, or is it that each measurement is stored individually in some sort of internal memory?
So I think the purpose of this was to set up an array of measurements where you knew how many elements there were, and that you could actually pick out the measurements themselves, because you knew A, how many there were, and B, the length of each one, and then you just had a concatenation of all the measurements joined together so that you could pick out individual measurements. We've had quite a bit of discussion about, well, how does this align to PCRs, and do we have enough information to behave like to behave similarly to the way a TPM acts?
Right.
So it felt like if we had an array of measurements that you could pick out, it lends itself to that behavior that you describe, and then you have a signature over the entire concatenation of measurement.
Okay. Yeah. I think PCR has sort of other benefits, and it depends on, it depends on the device and whether it can implement it. But you could imagine a PCR being something that's just in hardware, and then it only gets cleared on hardware reset. So there's no way for firmware to get compromised and change the measurement log after the fact. Whereas if it's stored in memory, then that's not possible. And then you also depend on the, this kind of goes down the road of essentially embedding some kind of mini TPM inside each device. So I don't know how helpful that is or feasible.
Well,
so I think in the model you're describing, you basically need the attester to have some sort of map of offset in the list and what that represents if they want to go in and cross-check individual values.
Okay, so sort of missing from this is the what, right? We got the array. You can pick out the individual measurements, but you don't really know what it belongs to. And it doesn't map to some set of PCR registers that a TPM has defined as PCR 0 is for this purpose, and et cetera, et cetera. Yeah. I don't know that you couldn't use this as in other words, given it's a protocol, there's two things that you can't guarantee about the endpoint with this, right? You don't know how these values were generated, because the protocol itself doesn't insist that they're hardware generated.
And that's fine. I think, the question is whether you get that list from the device through the protocol, or you just get it out of band from some spec and put it down into whatever it's your, agent or service that's going to look at them and compare them. It doesn't necessarily need to be part of the protocol.
Okay.
But, that's one take. Other people might feel differently, depending on how they plan to cross-check these measurements.
It's good feedback in the sense that we've had that discussion within the task force as to how closely aligned do we need to be? Do we just need to provide the place to put the data, or do we actually need to define that this place is associated with this type of PCR-like value? So we are talking about that topic within the task force. For the moment, the protocol just expresses it as an array of elements.
So you only have some hash value at the end. You don't know how you got it, and you don't have the detail to recreate it. Like you would in a TPM. In a TPM, you know exactly how each PCR is calculated, the algorithm, you can recreate it given the details. But in this is just the end result, and I guess you negotiate it how. Well, go ahead.
I was going to say, Elaine, even with a TPM, let's say for PCR 0, in theory, that it's the static portion of the BIOS, but in practice, there could be multiple extents to that PCR, and those aren't defined as part of the spec. So it really is up to you to sort of out of band through some document, figure out what is the actual list of extents that are needed to recompute the final value of PCR 0. And you can get the BIOS measurement log from the host, and it has some, I think, some PCG defined fields, but it also has some like vendor specific fields. So yeah, I kind of agree with you that it's good to have some sort of structure around it, but you can't have too much structure around it. In the end, you're going to have to go back to, in this case, each device vendor's specific implementation.
And couldn't they follow the TPM at least as far as if you had a log, this is what it would look like, and if you have a measurement with multiple detailed measurements, this is how it's calculated.
So I think there's an assumption here, and maybe it diverges a bit from the TPM. So I think an assumption is made that, rightly or wrongly, that when you go to negotiate with an endpoint device, you're going to agree on a set of methods to do computational work. That set of methods would be applied to all these measurements that you're going to reply to in the array. I think in the TPM case, you have multiple PCRs coming from multiple devices with multiple potential algorithms in use. So it's not entirely clear to me that you shouldn't know how that, because you negotiated down to something you were going to use, it would seem like you should know what each of these array elements and how they were computed with what hash algorithm, etc. Right? Even to the point of the signature involved, it should all be done as part of the unifying negotiate stage. So it's just unclear to me that it needs to be extended to the point that you can, on each individual measurement, you have a separate set of algorithms that could potentially have been in use.
Oh, that's not what I meant. I meant in your negotiation phase, you might have a response that says, my measurements follow the TPM style, for example.
Oh, okay. Well, we're still kind of battering about how these measurements should be done and how closely they need to follow, and whether the protocol needs to reference the TPM use case or whether it doesn't. So, part of the feedback we're getting from OCP is part of this part of the presentation is to get feedback, and so we'll talk about it back in the standards committee as to what we want to do with it.
I mean, there is the reserved parameter fields there that, if you wanted to architect some specific format of the response, that, one of those parameters could identify how to decode it.
Well, I think, I don't think you probably want to use reserved, because what happens in the future if that reserved is then used in an update or a minor version revision, then your OEM reserved, I think it would have to be defined as an OEM field.
That's what I meant. I just meant, instead of making it reserved, use it, just define a meaning for it that could be, how to decode the measurements.
Yeah. So the TPM method, I think, is good, but it's also very heavy for a lot of smaller microcontrollers and devices. For your UEFI and your OS measurements, the TPM framework provides a good structure with the TCG log that shows you how measurements were extended. But having that on non host platforms, for example, putting that on a microcontroller that sits on an SSD, it's probably overkill. But having something lighter weight is good. And I think, we implemented a very similar protocol to this in Cerberus, and it's been effective. We've had to adapt it somewhat to get onto, you always, you come out, you write an architectural specification, you start to march in that direction, and then as you get into your implementation, you encounter some things that change stuff somewhat. And some of the lessons that we learned kind of with MCDP, maybe in general, or with this authentication mechanism, and we use a very, very similar authentication mechanism. But some of the things we learned, like when you get into authenticating a PSU that has a DSP with 16K of SRAM, asking it for, or sending it, or asking it for its cert chain all in one go is a big undertaking. In fact, it doesn't have the memory to parse all the all the certificates in one shot. It can't take a full 4K message, so we've had to go in and refine our protocol a little bit to be able to take it in smaller chunks, or be able to distribute in smaller pieces. We like the USB authentication method because it does provide the cert chain functionality, which when you move out of like TLS and in some of those other network bound protocols, we have the ability to call out to some PKI infrastructure and determine the validity and the cert chain. It kind of lends itself well to that, having it network bound. When you come off of the network and you move into a platform root of trust, and that's not network bound, and is delegated some attestation responsibilities. Things like certificate validity, whether it's been revoked and you don't have the CRL of the PKI infrastructure, becomes a little bit challenging. When you don't have, UEFI uses a DVX mechanism, which is really, really good when you have intermediate or root certs. But when you have, per device or leaf certs, the DVX framework doesn't scale. So there's a, when we initially released the Cerberus protocol specification, we were working through some of the sub-device certificate revocation, and we had 3 or 4 different options we were circling on to mitigate or to bring in that feature. And we did so, but it required some minor changes to the authentication protocol and the measurement. So I think as you get into doing implementations here, or even mocking up implementations, you'll probably find some of those very similar things that we encountered.
Brian, did you end up with like one golden measurement per device, or do you still expect multiple measurements?
We permit group. We permit multiple measurements in a single measurement per device. The framework doesn't. Prevent having multiple measurements or a single measurement per device, but we base a single measurement on the platform. So we take a measurement from the platform root of trust, and we delegate some authority to that device. We think of it very much like, in the OS, you have a code integrity policy, and you measure or you attest your code integrity policy to make sure it's current. You don't attest everything that code integrity policy measures and enforces, if that makes sense. You don't measure every file in the operating system. Instead, you measure the code integrity policy.
Yeah, so the concatenation of the measurement in this example would be the thing that you would do to validate the device. You wouldn't go in necessarily and examine every element of the array, but you have every element of the array, A, to recompute if you need to, and B, check something that you were worried about. Like you could tell that maybe the hardware was altered because the measurement was off, and you go and look at the array of measurements and go, oh, array element 1 is the hardware, someone's altered it.
So you have a number of measures here, and then you have the measurement length, and then you have the concentration measurements. So what is the relevance there of the number of measurements? Like to me, that would indicate that you're actually going to provide an array of those measurements. And then if you look at this measurement response, and then you look at your digest response, you've got a measurement in both places. What's the difference between the two?
So we have using the device private key size. So I guess I didn't follow. So the signature is intended to prove the authenticity of the measurement. The measurement concatenation to me describes what you indicated, which was, hey, I'm probably not going to go interrogate the entire device and look at everything that got generated. So you know who it came from, you know what the entirety of the measurement is, and then if you really wanted to, you could go pick out each measurement from the return results that you get.
Yeah, I understand.
Okay. I mean, the number of measurements is to let you know how many elements there are, and the length is to let you know that, you know, once you go parsing the number of measurements, you know where to cut off at.
So if this, trying to translate this into something I know. So if this were TPM PCRs, let's say you had 5 PCRs you were reporting the measurements on, you would have those 5 values all concatenated together in this concatenation of all measurements. So you'd have 5 times 5 all the way across of the PCRs. And then each PCR will have its own detail somehow, which is not in here. Yes? Am I following it?
Each PCR could be picked out of that concatenated measurement.
Yeah, but the final value of the final PCR value is in that concatenate.
Yes.
Okay. Got it. And then that whole concatenation thing is signed.
Right.
I see.
Well, sort of the easiest way for me to think about it is just flattening out the 2D array of PCR measurements into a single dimensional array. And so you'll have to know exactly how many elements go into each PCR, but then you could sort of extract it from this list.
Yeah, and then if you
with the, you know, with what you were considering presenting, and I don't know if it's next week or in 2 weeks, you know, an attestation protocol. I mean, I guess how does that relate to this? Like, you know, is there like an alternative that OCP was going to propose, or I mean, if this is like sufficient, I mean, is it, you know, does it make sense to kind of define something else? You know, especially if another committee in a different organization is creating a very similar mechanism. I just kind of wonder what your thoughts were on, you know, at the attestation protocol you were looking at.
No, it doesn't make sense to define a new one. Absolutely not. But then even at a higher level, how do these things interact with each other? What's the order of presentation of these requests and responses is another question to me.
We owe you a ladder diagram of that. So the next time I come in, we'll bring you a ladder diagram of the order of operations. Because at the front of this, I sort of stated, yeah, the slides are more protocol-ish than order of operations-ish. And it's very important that we have the order correct.
Right. Because
But in practice, you there's nothing to enforce in the protocol and order. Right? You could skip stuff. You could do them in a different order. The protocol just defines the kinds of requests you can ask for and the kinds of responses you're going to get. The latter would be a recommended way of doing it.
I think this is a good first draft, Jeff, of something. I think I agree with Elaine. There's definitely benefit in aligning as opposed to having two different standards. That is, of course, if alignment and requirements can be met and reached. I think I have some questions on the protocol. I also have some things where I feel it might break down a little bit on you, and I can share those either in email or just on the distribution. What's kind of missing here is of course the get measurements response and the challenge auth response. In the challenge auth response, you have a device specific information which is kind of undefined. So maybe some more context as to what you would anticipate a device would put in the challenge auth response there. And then, like Elaine and others had mentioned, is how the measurements are calculated. Is it a concentration on how that concentration is generated and verified in the measurement response? And the other feedback I would have is really about compatibility with smaller devices. Like I mentioned earlier, if you have a DSP with 16K of SRAM, it's all tightly coupled memory. How would you have it use this protocol? Would you anticipate that some of the 4K payloads that it would have to keep a quarter of its memory free to parse some of the larger payloads, or is there a way to break them down?
Yeah, I've got a comment along the same lines. There are a couple of use cases that are in line with small memory implementations as well. Stateless peripherals, or is near, ideally driving towards stateless peripherals, and stateless servers. So, for example, one thing you find in the FIPS 140 requirements is that if you don't completely check out, you never do any encryption if you don't validate properly. And the FPGA or DSP examples that are given, or machine learning examples, or even trying to reduce the complexity and improve security of peripherals in general, it would be nice, and sometimes it's required, to have the PCI peripheral train its bus and then sit there waiting for a firmware download. It doesn't actually have any additional firmware beyond establishing communication with the host. And then in the case of a stateless server, you may have your root of trust in the BMC, and the server is, again, coming up, perhaps training memory, perhaps running caches RAM, and then establishing communication with the BMC to get its boot firmware. Again, driving as much state out of the system as possible so that there's less to check. You have a smaller TCV. So does the protocol support these sort of degenerate cases where you want the smallest possible implementation and you're still looking for a way to maintain your chain of trust?
So the first set of statements around sizing, I think when we looked at capabilities of parts, we had a different point of view. The limited resource case was really centered about algorithms and use, but I can certainly see we're going through the protocol. I think your slide example of certificate chains was a good one, where we probably haven't scrubbed through it going, well, The memory footprint of these endpoint devices is tiny. It's capable of doing this type of protocol, but it's not capable of processing the entire cert chain at once. So we arguably need to go through and look at that. Your second set of statements seem to be around more about devices that inherently at startup do not have a lot of firmware capability within the device itself. And your question was like, well, how do I prove out the state of that part that really doesn't have any state from the beginning in terms of firmware capabilities?
Yeah, the design drives towards minimal state.
Yeah,
it's not that you couldn't run the firmware, it's just that you would want to get rid of it.
Yes, I'm a little maybe cross-purposed here. So I don't know that the protocol was it's intended to provide the mechanism for exchanging of information. It doesn't really put any qualifiers around how an endpoint accomplished that work. So and I'm not sure it should, right? If you embodied all of this into gates and you didn't need any firmware to do it, and you can respond to these requests, that's great. But the protocol itself assumes somewhat that you've built up an MCTP stack, right? That can communicate over VDM, by example. So maybe I'm missing your point, but it seems a little disconnected to me. I like your idea, though, by the way. Minimal firmware on the platform, less state on the platform, less reason.
Yeah, I'm not saying implementing gates. I'm not saying that there's no firmware. I'm just saying we're trying to drive the complexity of any endpoint to as close to zero as we can. Of course, that's going to be asymptotic.
I think there's a sort of design space question here about when you do this attestation or challenge response protocol. Because if you have a stateless device that, for let's say, is downloading its firmware over a PCIe link, you're right that maybe you put it in Mastrom and you do have an MCTP stack in there and you can do this right at the beginning, but you don't necessarily have to. If you're willing to assume that when the device comes out of reset, it's in a trusted state because it cannot have any firmware on it, and then you trust your ROM to properly do the signature checks, you could allow the firmware to download, and the firmware itself could have the MCTP stack, and then do the attestation at a later point. That does leave open the possibility that somebody finds a 0-day in your ROM and et cetera, et cetera. So there is a small window there. So it kind of depends on how you want to look at the security of the system.
And then I'm not really sure how that ties back to the protocol.
The 0-day threat is going to be in any implementation,
right?
And it's less likely in the minimal implementation.
Right. So is there something that prevents you from doing the attestation after the firmware is loaded off of the PCIe device?
Well,
I'm not trying to propose a solution. I'm just trying to throw out ideas here to say that it depends on how you think about the security of the device. If you're off the platform, if you think about it in sort of the Cerberus viewpoint, which is nothing exits power reset until it's been verified, then yeah, it becomes complicated to have to run this kind of protocol beforehand.
One has to look at the design, what your assumptions are, but it's debatable whether the more complex attestations are necessary. Once, in the case I was talking about, where the bulk of the firmware is uploaded from the host, and the host is maintaining the chain of trust, extending it to a peripheral in this case.
Right.
Whether that attestation is needed after that firmware download and verification that it was received and executed.
I think you would find that your you're still requiring attestation on the peripheral, irrespective of who gives it firmware or what gives it firmware. What if it's already running firmware and it tells you it's not? And you give it your firmware and you think, great, it's got my firmware, but it's got the firmware that it already had and it lied to you.
Yes, I mean, there's always the possibility that someone's installed a peripheral that has two parallel implementations and it maintains one purely for giving you the attestations you're looking for, but it does all the work with the rogue implementation, the malicious implementation. Certainly that's possible. My question really is, and I haven't looked at it closely enough to answer this for myself, but does the proposal overcomplicate the minimal case? That's basically my question.
Yeah, I think what you're looking for is a different mechanism. Like you're like, okay, if you're saying that this is the way to do it, then you need all these other things. And it's not really a critique of the protocol itself. I think you're asking a higher level question of, should we even be using this protocol?
I think the question, as I understood it, was what is the minimal stuff you need to get to attest your device? And
yes.
Then it's how do you get it is kind of a follow-on question.
Okay.
And I think sort of related to that in my mind is if you can't get that minimal stuff going at power on reset, or when your link comes up, then what trade-offs are you making in terms of security?
If you can't get that set at power on, what trade-offs do you make in terms of security? Was that your question?
Yeah.
Okay. So I think that was more of a question to think about than it was you're looking for a specific answer at the moment.
Right. Like I say, I haven't studied it to allow myself to answer the question independently.
Yeah. Well, I think these are all good questions, right? The minimalistically of the device. What if I was going to architect this a different way? This makes some assumptions. What we presented today. So we're sort of kind of out of time for this session, I think.
By a lot. Yeah.
By a lot. So what I'm going to do with others is probably go back and replay our discussion today for notes against the presentation. I don't know what's next on the agenda for next week. Maybe even next week we should come back and maybe spend a portion of the session talking about the open-ended questions that we had today, just so that, or we can discuss them in email as part of the group too.
I think we can do both, Jeff. We can give some time next week to feedback. And responding to feedback, I'll provide you and the group some in email, and then because there's no, normally there's a document here, and folks will be marking it up with questions, and you go to that. So I think maybe for some emails on feedback, and then we can address some of that next week.
Okay.
Up next week, I think we also want to close out on some open questions with Secure Boot. But yeah,
so in the agenda next week is Secure Boot, and then 29th is attestation with Elaine. So Brian, I don't know how much time you're going to take up for Secure Boot, or how much you still have as open questions.
Yeah, we can do 30 minutes. I can keep it down, and then we can circle back and do 30 minutes for Jeff. So split the time next week. Does that work, Jeff?
Yeah, no, that's fine. I need to figure out why I'm not getting the subscribe security project email, even though I did it. So maybe I'll get with someone later and they can help me figure that one out. But I think 30 minutes next week is fine.
All right, cool. All right, thanks a lot, folks.
Yep.
Take care.
Bye.
All right, thank you.
Thanks, everyone.
Bye now.